Fractal Principle. The sum of the sides of a polygon is slightly greater than the value of its perimeter because when adding, we always add twice the points joining each side. See drawing. All of this is due to the characteristics of the dimensional structure of non-Euclidean space. See my work on this subject, which tells us that there is no such thing as a zero space point, or point of no value. Rather, a real dimensional point will always exist, even if it has an infinitesimal value of space. And so, we can imaginatively cut or join two segments of the same line, without losing or gaining space, but we cannot join two lines at an angle since, for the lines to be joined, their endpoints or coinciding points must be joined, and adding them separately will give us a value greater than the perimeter of the whole or figure formed. And if the lines, sides of the figure, were not truly joined, they would not form a complete figure. But moving away from this theoretical preamble, what interests us is the aforementioned fractal principle. The sum of the sides of a polygon is slightly greater than the value of its perimeter, because when adding, we always add twice the points of connection of each side. And this applied to the adjustment of pi by adding the sides of polygons inscribed or circumscribed within the circumference. According to Archimedes, it would lead us to the conclusion that the number pi thus obtained must be slightly greater than the true value of pi. That is, if we add the sides of inscribed polygons of a quasi-infinite polygon, the result will be that the value obtained will be slightly greater than what the true pi should actually be. How much greater? Well, it seems that the cut or coincidence can occur in a polygon with around 4090 sides, but of course, that would have to be adjusted better than I have done. And the series seem to have the same flaw or defect. If they represent the transformation of curvatures into straight lines, then they will follow the same principles of union and geometric structuring that we mentioned before. Now, referring to the true value of pi, I understand that I have already written and published quite a bit about this, and they are included in the accompanying drawings. The number pi should be obtained as a direct function of the only parameter we know about the circumference with respect to pi, and that is the value of the diameter of the unit circumference with radius 1 and diameter 2. That is, 2 is the only known value that should lead us to pi. Of course, the values of the inscribed and circumscribed squares within the circumference are also functions of 2. However, playing with the value of the diameter 2, and using the Pythagorean theorem with the inscribed and circumscribed squares, and their right triangles, we can find the appropriate powers and roots to find the correct number pi. As we can see, the smallest power of pi that connects us to the diameter of the circle and to the sides of the squares inscribed and circumscribed within it is the number 17. That is, with the 17th power of pi, we can connect with the power of 2 and the powers of the squares inscribed and circumscribed within the circle. Even with the other magic number, the number phi. But as I've already said, there is much written and published on the subject, so I'm showing you drawings that show all these principles and adjustments for pi. Thank you very much, friends.